Hello, everyone. Welcome back. So today I'm going to go ahead and talk about factoring quadratics in standard form. This is going to be very much an introduction to it, so I'm assuming you don't have any prior knowledge on how to do this already. So I'm going to start from the very beginning. So what is a quadratic in standard form? So a quadratic is a degree 2 polynomial, or in other words, a polynomial where the highest power is 2, right? Hence degree 2 polynomial. Okay, so that's what I mean by a quadratic, right? A degree 2 polynomial is a quadratic or a parabola when we graph it. And in standard form, they look like this: ax squared plus bx plus c, right? So basically some number times x squared plus some number, right? Some constant times x plus some constant c is what they look like. Now keep in mind all of these a, b, and c can be any real number and it's a quadratic, except a cannot be 0. Because if a is 0, then we can just get rid of this term and we have just plus bx plus c, and that's clearly not a quadratic anymore. That's because that's a degree 1 polynomial, right? And so that's a lie, right? Bx plus c looks suspiciously like mx plus b, which is a line form. So a cannot be equal to 0, but other than that, a, b, and c can be any real number at all, and it's quadratic. So how do we factor them? Well, as you'll notice, with these ones, I'm going to show first in this one, we're going to do a part 2 to this, where we don't actually have any a value that isn't 1. For all of these, you'll notice a is 1, 1x squared, 1x squared, 1x squared, and so on. For all of these, later we'll get into ones where we don't have the 1 in front, but for this one, for this lesson, we're just going to talk about ones where we have 1 in front. So you'll notice we have two numbers. We have b and we have c. Basically, we need to find two numbers that multiply out to c and add up to b. Okay? Now, how do we find these numbers? Well, trial and error. However, I'm going to give you some tips on how to find them faster. The thing is, there's any number of things that could add up to 2, right? There's so many different possibilities. It could be 1 plus 1, could be 0 plus 2, could be 3 plus negative 1, could be uh, 4 plus negative 2, right? There's just so many, right? But the thing is, when it comes to multiplying to negative 15, there's only so many options, right? There's only so many factors that any given, especially we're talking about whole number factors here, right? There's only so many whole number factors that, that work with negative 15, right? There's 1 and 15 and negative 1, negative 15, 3, 5, negative 3, negative 5, and then that's it, right? That's all. Okay, and so rather than finding a bunch of things that add up to 2 and then seeing if they also happen to multiply to 15, I strongly recommend doing the opposite. Find things that multiply to negative 15 or whatever your c value is first, and then see, do any of them happen to also add to negative 2, or sorry, positive 2 in this case. So let's do that. I'm going to write out the options. 1 times negative 15, negative 1 times 15, negative 3 times 5, and 3 times negative 5, right? So there's actually only 4 multiplication equations I could even come up with, right? So which ones of these would add up to 2 if we were to add them together? Well, 1 minus 15 would be negative 14, so no. Negative 1 plus 15 is 14, so no. Negative 3 plus 5. Well, there we go. Negative 3 plus 5. Well, haha, that is 2. That is 2. And so that's our answer, right? So it's trial and error, but there's ways to make it go a lot faster than just trying a bunch of things, hoping something works out for you. Okay, so now let's factor this. Our numbers we got were negative 3 and 5, so x minus 3 and x plus 5 is going to be our answer. Now, something I want to remind you about with factoring is not changing an equation. Factoring is changing the form of an equation. I know I will sound like a broken record, but I will continue to say this many, many times throughout this entire unit. Okay. And so, how can you check that you did the factoring correctly other than just repeating the same steps we already went over and making sure you did it correctly? Well, you can expand it, right? In the very first lesson of Unit 3, I went over how we can expand these. I think it's called multiplying. It's either called multiplying binomials or expanding quadratics, one of those titles. And it goes over how we can actually take this and get this form back. So if you expand it and you get the same form back, you've done it correctly. If you expand it and you don't get the same form back, either you expanded incorrectly or you factored incorrectly, and that's a problem, right? Or another way you can kind of check if you're allowed to is you can, like if you're just practicing, you can check this way as well. If you'd like to on a test, this might not always be allowed, but you could put this equation into Desmos or Wolfram Alpha or some other graphing calculator, and then same with this equation, and then you should see that they're the exact same equation. Or if you type one of these into Wolfram Alpha, it'll say factored form and then the second one, or if you type in the factored form, it'll show you the standard form in Wolfram Alpha, right? So it'll show you that really these are the same thing, but just two different ways of, two different ways of expressing it, right? In this case, we're in this exercise, we're just talking about factoring. I'm not going to really talk much about why factoring is useful, but it can be useful for solving equations later, which we will get to. Okay, let's move on to example 2. Example 2 says x squared plus 12x plus 32. Okay, so we need two things that add up to 12 and multiply to 32. So again, if we try to come up with things that add to 12, there's so many. There's only so much that can multiply to 32. And also in this case, we don't need to include the negative ones because of course negative 1 times negative 32 as an example would multiply to 32, but we know that 12 is positive, so we just need to find positive things, positive times positive that multiplies to 32, because those are the only things that could possibly add up to a positive number like 12. Okay, so my first answer is 1 times 32, 2 times 16. 3 doesn't work. What about 4? 4 does work. It's 4 times something or other. Let's see. 4 times 9. Is that right? Yes, it is. Yes, it is. No, that's not right, is it? It's 4 times 8. My apologies. 4 times 8 is 32. What about 5? No. 6? No. 7? No. And there we go. Okay, so as you can see, we only have 3 choices here, and it's pretty quick to say, oh, well, 4 plus 8 is 12. 4 times 8 is 32. Voila, we did it. Whereas imagine if we'd come up with all the things that multiplied or that added up to 12, it would have taken forever, right? There's so many, I don't even want to begin to list them. But here with 32, there was only 3 choices, and so it was very quick and easy to see what the answer was. And I think that's the most common mistake students make, is they'll try to find something that adds to B before they try and find something multiplied to C. And I always say, definitely do the opposite. It'll be a lot faster. It's not that you can't get the answer by doing it the opposite way, but it could take you much longer. Okay. All right. So for example 3, what are two things that multiply to 60 and add to negative 4? Well, let's see. Negative 1 times 60 and 1 times negative 60. Let's see. 2 times negative 30 and negative 2 times 30. 3 times negative 20. Negative 3 times 20. What about 4? Yes, 4 times 15, or 4 times negative 15 rather. And then negative 4 times 15. Okay. And then what about 5? 5 times negative 12. Negative 5 times 12. 6. Negative 6 times 10. 6 times negative 10. And I think that's it. So as we can see, in this case, there are a lot more, partly because it's a negative number, and just 60 has a lot more factors too than the previous one. But all these ones up here, clearly aren't going to be 4. Let's look at the bottom first, actually. Very last one. Negative 6 times 10, right? 6 times negative 10, because 6 plus negative 10 is 6 minus 10, which is negative 4. And there we go. So therefore, answer is x plus 6, x minus 10, and there we go. Awesome. Okay. All right, let's move on to the next one. And actually, let's just put the actual answer here because we don't have a lot of room anymore. I need room for this next one. Okay. What are two things that add up to negative 14 and multiply to 24? So in this case, it's the opposite in as a number 2, because you'll notice our b value is negative, so we only want negative numbers here. So I'm going to ignore all positives. I'm only going to put negative numbers here. So negative 24, that could be negative 1 times negative 24, could be negative 2 times negative 12, negative 3 times, I mean, doesn't matter because the last one is actually going to be the answer, but let's just finish this for argument's sake today. Let's see, negative 8. Okay. And then I guess negative 4 times negative 6. But now the answer is this one here. Negative 2 minus 12 is going to be our answer. So this is equal to x minus 2, x minus 12. And there we go. Awesome. Okay. Now let's move on to the next one. All right, so we need two things that multiply to negative 12 and add up to negative 13. Now again, since negative 13 is a negative number, I only care about negative things that multiply to 12. So I only care about things like negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4, stuff like that, right? Because these are the only things that could even possibly add up to something negative. 1 times 12, 2 times 6, and 3 times 4. Well, those are positive numbers. Adding up positive numbers always gets us positive numbers, right? There's no way around that. So what's our answer here? Well, negative 1 minus 12 gives us negative 13. So there we go. Awesome. So then we have x minus 1 and then x minus 12. And voila. All right, let's do two more examples, and then I will be done for this one, for this version of factoring quadratics. Let's find two things that add up to 10 and multiply to negative 24. Well, let's see, negative 1 times 24 and also 1 times negative 24, negative 2 times 12 and 2 times negative 12, 3 times probably some stuff, not that it matters, but 3 times. There we go. Okay, so what's our answer? This one here, because negative 2 plus 12 gives us 10. Okay, so then our answer would be x minus 2 x plus 12. And there we go. Awesome. All right, and let's do one last one here, where we need to find two things that multiply to negative 18 and add up to 7. Okay, so let's do it. And for negative 18, we have, let's see, negative 1 times 18, 1 times negative 18, 2 times negative 9, negative 2 times 9, which is going to be our answer, negative 3 times 6, and 3 times negative 6. Okay, so negative 2 plus 9 is going to be our answer for what adds up to 7, and negative 2 times 9 gives us 18. So there we go. Our answer is x minus 2, x plus 9, and there we go. All right, well, that is it for today. Next day, I'm actually going to tackle with everyone part 2 of factoring quadratics in standard form, where this time we have actual values other than just 1 for our a value. And this one, all of them were just plain old x squared with no coefficient other than 1 in front. Next time, we'll talk about how can we factor it when that's not the case, because that will not always be the case. But anyways, good work today, everyone, and I will see you next day. Bye, everyone.